Hello guys. Uh, so today I want to solve a question from source. Here is JEE Advanced 2020. Found it. Uh, the question it talks about the area bounded between two functions. So the question states that now let the functions f map from a real to real, and the function g map from real to real be defined by, now the function f of x is equals to e to the x minus 1 minus e to the quantity negative of absolute value of x minus 1, and the function g of x is equals to 1/2 times the quantity of e to the x minus 1 plus e to the 1 minus x. So what to find is find the area bounded in the first quadrant bounded by the curves y equals f of x, y equals g of x, and x equals to 0. So now the first thing I see here make a bit of confusion is the absolute value right there. You know that this one, right? So my idea is to make the function of f into piecewise function, because absolute value can be made into piecewise function. So first f of x equals to, now find the roots where the absolute value is equals to 0. No, because x minus 1 equals to 0 and x equals to 1. Now x equals to 1 is the root of this absolute value right here in the exponent. So say x less than 1. For x less than 1, so it becomes negative, right? So it's negative times the value which is negative, so it's still positive in the absolute value. So it written like this: e to the x minus 1 minus e to the minus of x minus 1, like that. And for the x greater or equal to 1, e to the x minus 1 minus e to the minus of x minus 1, just like that. This is for x greater or equal than 1. Now if we simplify this part right here, it simplifies to 0, right? Because negatives times negatives is positive, and these quantities, two quantities right here, is just the same, so it makes 0. I'll just make it right here. Oh, I'm sorry, it's 0, and e to the x minus 1 minus e to the we can distribute the minus, so it's 1 minus x. This is for x less than 1, and this one is x. Alright, now let's see how about we make the rough graph, just roughly. We're not calculator here. If you want to know the graph, go to Desmos, or any graphing calculator you have. So when x less than 1 when x less than 1 is equals to 0, so that means all the value is equals to 0 behind 1. So let's say this one. Now for x is greater than or equal 1, it's right here, e to the x minus 1 minus e to the 1 minus x. Now let's make it like this. It's exponential, right? So you know the graph of exponential function is like this. You can make it like this. So just f. Now how about the g of x, the function of g? Now let's see. Now how about we make what is the value of g of 1, right here we know that when x equals to 1, its value is 0. So e to the 0 right here and e to the 0 right here. So really it really is 1/2 e to the 0 plus e to the 0. So 1 plus 1 equals to 2 over 2 equals to 1, right? Now it's about right here. That's g of 1. Now how about g of 0? But we don't care about g of 0 because we know that if you don't believe, just find the value. But we know that g must be greater than f, right? Because of this exponential, it's always positive, and the f is 0 when less than 1. So in fact that g will be greater than f in the interval negative infinity 1 1, right? So let's make it's rough. I don't know, maybe it's like this, right? Now how about this one, right? Like any question like this, you will find the intersection of the two functions, right? So let's find the intersection of f and g. How to find that is really easy, right? So it's fx equals to g of x, right? Now we choose the one for the x greater than or equal to 1 because the intersection must be right here, greater than 1, not behind the 1, right? So we choose the positive one. It's x minus 1 minus e to the 1 minus x right here. Now that's equals to 1/2 times e to the x minus 1 plus e to the 1 minus x. Now that simplifies to 1/2 e to the x minus 1, and this one minus the 1/2 e to the x minus 1 on both sides. So you got this one on the left side and minus this one, so you got this on the left side. Now you can multiply it by 2. So you got e to the x minus 1 minus 3 e to the 1 minus x equals 0. So that x minus 1 equals to 3 e to the minus x. Now let's make the natural log. Now by the property of logarithm, it's just equals to this, and this one is just this. Now this one is multiplied, so by the property of logarithm you get addition. Let's just directly put like this. So 2x 2 plus 3. So x equals to 1 plus 1 half. Make it easier. Oh, right. So from the property of logarithm, you got 3 to the 1 half power. It equals to root of 3. So now, right. So this is the intersection, right? The point of intersection right here is actually 1 plus natural log of root of 3. So now, let's integrate the area. So the area, the area is equals to, let's integrate from 0 to 1. You know, from the equation and x equals 0, it's actually just a vertical line at x equals to 0. So don't much care about that. Right? We integrate from 0 to 1 of gx. Because of fx equals to 0, you want put it in right here again, right? So gx minus 0 is just g of x, right? So now in the point, right, 1 to the 1 plus natural log of root 3, it's g minus f. So g of x minus f of x dx. Now once again, if you don't believe that gx is greater than f of x, right, in the interval of between 1 and 1 plus natural log of 3, you can just evaluate integrate of g of x and integral of f of x, right? You can just evaluate that and you know which one is bigger than another one. If you look at the graph, you notice that gx, this is just rough graph, right? Gx is actually greater than f of x. The curve is on the f of x. Now let's integrate. Let's make one half right here. It's constant. Plus 3 g of x, like 1 half e to the x minus 1 minus 1. I distribute the 1 half on the other side minus the f of x. Now the f of x right here is greater than or equals to 1, so it must be e to the x minus 1 minus e to the 1 minus x. Now this equals to e to the x minus 1. Now this one is negative, right? E to the minus x. You can just use substitution. Now this one right here is integral 3 minus 1, and this one is positive, so 3 2 e to the 1 minus x, and e to the 0, e to the 0. Substituting the 0 right here, you got e inverse minus e, right, plus just the same as this one, then one. Now this one equals to 1/2 times this one is 0, 1 minus 1 0, right? So this one E minus E inverse. No, you distribute the multiply by negative right here. So you got this. Now add 1 plus natural log root 3 minus 1 minus 3 1/2 3 1/2 e 1 minus 1 plus natural log root 3. Now minus 1/2 e to the 0 0 2 e to the 0, and thus notice right here we can just eliminate one negative right here, just negative here. And this one is negative natural log of root of 3, so you can make that into natural log of 1 over root of 3. Natural log of 1 over root of 3, when you rationalize that, you got this one, right? So the natural log is written like this by the property of logarithm. So now you got the 1/2 root of 3 minus 3 over 2 times root 3 over 3, and this one negative 1/2 minus 3 over 2 is negative 2, negative right here again, so you add 2. Now and it's done. You got, and this one is negative 1/2 minus 1/2 is negative 1, so 2 minus root of 3. Alright, so it's done. So the answer is A. Yep, pretty much the same, right? Alright, so the area is 1/2 times e to e minus e inverse plus 2 minus root of 3. So that's it. Alright, that's for today's question from JEE Advanced 2020.